Hello everyone, my name is Jesus Davila and I'm the Operations Manager for RMS Energy. Today I'd like to talk to you a little bit about the importance of maintaining your bus system at your plant. By and large, it is a system that is ignored simply because it doesn't have any moving parts or doesn't make any major noise. Unfortunately, this is far from the truth, and maintaining your bus is critical to the operation of your plant. Your bus system is one that is not redundant and usually does not have any type of backup system. And so once it goes down, your plant is down and you stop making money. It is very important to maintain and put together a comprehensive maintenance program for your plant and your site. And this is what I'd like to talk to you a little bit about today.
I'd like to tell you a little bit about RMS Energy and what we do. We are primarily a service company for bus duct systems. It's what we do 365 days of the year. Isolated phase bus, segregated phase bus, non-segregated phase bus, and cable bus. Although we also work on switchgear and transformer equipment as well. Aside from that, however, we also focus largely on safety. It is very important to us and paramount to ensure that our crew and others working at the plant are safe, and we are proud to boast an industry-low EMR rating of 0.66. So not only are we focusing on your specific problems and your specific bus duct needs, we're also focusing on safety. Moving on to the different types of bus, I'm going to be primarily focusing on isolated phase bus and its components. However, I'll also briefly mention some of the other bus systems that you'll find in your power plant. Cable bus is essentially cable running through a common enclosure, normally aluminum, and held in place along the run by cable support blocks. We maintain and install cable bus quite regularly and can certainly put together a comprehensive plan for you for your specific system. Non-segregated phase bus is essentially 3 phases, all inside a common enclosure. The enclosure is typically aluminum, although it can also be stainless steel, and the conductors themselves are either copper or aluminum and can be either bar or square. Another type of bus that is similar to this is segregated phase bus. And it's essentially designed the same way where all 3 phases are inside a common enclosure, but each phase is separated by a metallic wall. It provides just a little bit more reliability and safety. Moving on to isolated phase bus duct, this is the system I like to focus on for the sake of this presentation. And isolated phase bus, each conductor is housed in its own enclosure. Usually the conductor is aluminum and the enclosure is aluminum, and each enclosure is separated from one another by air. Isolated phase bus duct can carry anywhere from 7,000 amps up to 50,000 amps or more. And depending on the design of the system, the older the system, the more challenges it poses for maintenance. And I'm going to go ahead and break down a couple of those key components here for you now. As we look at the connection points, the termination points to your transformer, to your generator, to perhaps a generator breaker or other equipment such as PT cubicles, excitation transformers, aux transformers. Every one of those will have a termination point made up of connectors, typically copper connectors, sometimes laminated copper connectors, other times braided copper connectors. These connection points are essentially your weakest link, and if they're not maintained properly, you'll see all kinds of problems. Some of the things to keep an eye on are the contact surfaces, ensuring that the silver plating is in proper condition. Also, the hardware that is used to link up all your connectors, they need to be uniform and torqued to the proper value. Many times we go in these plants and look and inspect these connection points and come across different size hardware, different size bolts, different size flat washers, and different size conical washers, all for the same connection point. It's imperative to ensure that your hardware is all uniform and again that your torque value is set properly. Aside from the hardware and the contact surfaces, you also want to make sure that your flexible connector is also in good condition. Laminated connectors pose its own problems. Braided connectors have other types of problems, and I will be going through those a little bit here a little later. But it's very important to ensure your termination points are kept properly, or you will suffer heating issues and other damaging problems. As we move into the bus, the conductor is held center inside the enclosure by porcelain support insulators. These porcelain support insulators are susceptible to cracks, hairline cracks, dirt, debris, moisture, all of which can cause some major problems. And so it is very important to ensure that these insulators are maintained properly. If you have a regularly maintained system, then every 18 months is adequate, and you can actually spot check them, perhaps every third or fourth insulator, to ensure that everything is in proper condition. However, if you do not maintain your system properly, it is highly suggested, that you inspect every one of those insulators thoroughly throughout the entire run of the bus. Another component that's also critical inside your system is expansion joints and your expansion bellows. Expansion joints allow for contraction of your conductor, and they're primarily made up of aluminum shunts welded on one side of the conductor and then welded to the next section of conductor on the other side. Now, these laminated shunts can start cracking, delaminating, and eventually perhaps even fly into your bus, causing some major problems. So it's very important to ensure that your expansion joints are looked at periodically. Likewise, the expansion bellow provides expansion and contraction of your enclosure. The expansion bellow can be made up of rubber or aluminum. In either case, though, if they're not maintained properly, they can start cracking, degrading, allowing debris and other elements to go in, such as rain, snow, and so forth. This can cause major problems if it penetrates into the bus, as well as heating problems, because now the continuity of your enclosure has been compromised. And so now you can have some heating problems as well. Another component of your bus system to maintain is your seal-off bushings, or any seal that you might have, say through a building wall or a firewall, or at the ends of your bus runs, such as at the transformer or at the generator. Seal-off bushings are designed to keep fire, hydrogen, other debris from penetrating the bus. And it is very important to maintain these and the integrity to be maintained. Otherwise, you're compromising now the safety of your bus. And the insulating bushings can crack, or the seal can crack as well, compromising that seal, of course. And now you can have some major problems, or potentially major problems. So to recap, some of the major components to ensure that are in good working condition are your termination points that are made up of your flexes and your bolted connections. The contact surfaces need to be properly maintained, the silver plating intact, your flexible connectors themselves in good condition, hardware uniformed, and torqued to the proper value. Your expansion bellows and expansion joints. You want to make sure that those expansion joints, the laminations, are in good condition, not cracking, not delaminating, and the welds are intact. And for the enclosure, you want to make sure that that expansion bellow is in good condition as well, no cracks, or it will allow the elements to penetrate, and heating issues will also develop. The insulators and its mountings, very important to maintain. Make sure that those insulators are not cracked. Make sure that they don't have any hairline cracks, debris, dust, moisture, as well as the mountings that can come out of the insulators as well. Depending on the design of your bus, the insulators can be under a lot of stress, and those mountings can sometimes start slipping out, and the conductor is now compromised inside your enclosure. Your seal-off bushings, as I was just mentioning, and very important to ensure that those are in good condition, ensure that there are no cracks, and that the seal is properly maintained. It's particularly in your firewalls or building walls as well. You want to make sure that those seals are in good condition as well. Grounding is very important. I did not mention this earlier, but grounding is a very complex subject, and if your bus is not properly grounded, you can start experiencing circulating currents, heating problems, and it can be very difficult to detect its origin. So it's very important to follow the OEM's suggestion, recommendations on how to ground a bus, and we can certainly help you with those issues as well. And in general, all your insulated joints, they can be made up of tape or insulating boots, but your insulating joints need to be properly inspected so that there is no arcing or tracking of any kind. This mostly holds true with non-seg bus or segregated phase bus. Some samples here of what you might see and what can lead to major problems. Here I have a picture of a laminated connector. This connector is delaminating and cracking. Now, if those laminations completely come off and fly into the bus, it can be catastrophic. Your older bus designs, dating back to the 50s and 60s and even 70s, you will see this laminated connector design. And we are being asked more and more lately to go in and modify the bus to retrofit in a braided connector termination design. The braided connector is a little more reliable, easier to handle, and even the lead times are shorter in case you ever need to replace one. However, as you can see in the picture here in the bottom right-hand corner, they come with certain problems themselves if they're not installed properly. This is the case where the connector was not properly installed and it started to burn and fray at the rubbing point. So it's important that they're also installed properly. If the warning signs are not addressed, then you start getting into larger problems. Here I have a picture on the left-hand side of the enclosure starting to melt because those shunts are not properly bolted. And so there's some heavy heating problems, and now the enclosure is starting to melt. Those shunts are starting to melt into the bus, and that can cause some major problems. The center picture here is an example of a connection point that has not been maintained properly. Fortunately, this specific connection point had not failed yet, but it was certainly due to fail, and it was taken care of, but this is just how a connection point can end up looking if not maintained properly. On the right-hand side, you see some embossing in a copper bar. Under-torquing can pose problems, and over-torquing can pose problems. If you have some embossing, now you're compromising the contact surface of that copper bar, and thereby causing some major heating problems. Here, moving on to the next slide, we have a couple of samples of expansion bellows with cracks in them. Now, these cracks are very difficult to detect, especially from the ground. But this crack can definitely hamper your bus system's performance. Now you have a spot where you can have water penetrate. This connection point here is definitely heating as well, because the continuity of your enclosure is now compromised. And so it's very, very important to ensure that the expansion bellow is inspected all the way around. Sometimes the top part of the expansion bellow is very difficult to see, but it's imperative to ensure that the integrity of that expansion bellow is maintained all around. Here there are a couple of pictures of some obvious cracking of your porcelain support insulators. This is obvious and easily detectable. However, as I mentioned before, something as simple as a hairline crack can give you problems with your support insulators, and it's very important to ensure that they're maintained properly, cleaned, and free of moisture and debris. And here are some samples of problems getting bigger if things are not addressed in time. We have some melting of an enclosure on one picture, and a connection point failing due to overheating in the other picture. Here I got a couple of pictures of some blow-ups. Actually, this is a picture of one showing what to do, as a matter of fact. This lower picture here where you see the enclosure melted completely off, this is a prime sample actually of a properly maintained seal at that firewall. You can't see it, but on the other side of that wall, the bus is maintained and in good condition and was saved. And so this unfortunate incident was just maintained, or actually the issue was just honed in on this side of the wall. And again, downtime and cost was mitigated because of a properly maintained firewall penetration. So going back to ensuring that your seal-offs and your penetrations are in good condition, this is the reason why.
Thank you for your time. Every system is different, and we'll be happy to customize a comprehensive plan for yours. Please contact us directly at the number below.